In the quiet dawn of the Yamanashi Mountains, a revolution in transportation begins as we enter the high-tech facility where the fastest train on Earth is born. The SCMaglev L0 Series is more than just a vehicle. It is a masterpiece of Japanese engineering designed to conquer the limits of physical speed and distance. Clocking in at a world record speed of 603 kilometers per hour. This machine redefines what is possible for ground-based travel in the 21st century. Before it can fly on a cushion of air, it begins as heavy, raw industrial elements, waiting to be shaped by the most advanced manufacturing techniques available.
The tolerances here are
Every
tighter than the
curve and
previous
every
model.
bolt is
Ensure the robot
meticulously
compensates.
planned by elite
Understood.
engineers,
We'll run the diagnostic
ensuring that the
sequence now.
final structure can withstand the immense pressures of ultra-high-speed travel. Step inside the heart of production, where traditional Japanese craftsmanship meets cutting-edge robotics to build the future of the Chuo Shinkansen line and beyond. With a focus on aerodynamics and magnetics, the L0 Series aims to shrink the distance between Tokyo and Nagoya to just 40 minutes of travel time. The transformation from raw metal to a speed demon involves a series of complex phases, starting with the most iconic part of the train, its nose. Part 2, the art of casting. Molten aluminum alloy is poured into massive molds at precise temperatures to create the foundation of the 15-meter-long nose. This ultra-lightweight material is the secret to the train's agility, providing the necessary strength without the burden of excessive weight that would hinder top speed. Even with advanced robotics, human intuition remains vital. Master craftsmen inspect every inch of the nose to ensure the aerodynamic profile is absolutely perfect. A laser measurement system verifies the curvature with a tolerance of less than 0.1 millimeters, as even the smallest imperfection could create massive air resistance. This unique, elongated design is specifically engineered to eliminate the sonic boom effect that occurs when trains enter tunnels at extremely high velocities. The surface is then treated to be as smooth as silk, allowing air to flow over it with minimal friction, maximizing energy efficiency during operation. Once the casting and shaping are complete, this massive aerodynamic component is moved to the primary assembly line to be joined with the main body. Part 3, laser technology. We use friction stir welding and high-precision lasers to create seams that are virtually invisible and stronger than the surrounding metal. The car body is constructed using a honeycomb structure of aluminum, providing extreme rigidity to handle the intense air pressure at 600 kilometers per hour.
Okay,
Every
right there.
weld
Hold it
is a
steady.
work of art, uniform and flawless,
Hitting the torque now.
ensuring
Looks
that
good.
the structural
Check the
integrity
schematic
of
for
the
the next
cabin
one.
remains uncompromised during its decades of service. Inside the shell, a complex skeleton of support beams is installed, designed to absorb vibrations and provide a stable environment for the passengers inside. Kilometers of specialized wiring are threaded through the frame, connecting the sensors and control systems that will act as the train's central nervous system. Artificial intelligence-driven scanners then analyze the entire structure in 3 dimensions, searching for microscopic defects that the human eye could never possibly detect. With the fuselage complete, the train is now ready for its most critical component, the superconducting magnets that will allow it to levitate. This hollow shell will soon house the heart of the maglev technology, a feat of physics that defies gravity through the power of magnetism. Part 4, the superconducting heart. We move into a Class 100 cleanroom, where even a single speck of dust could compromise the superconducting magnets. These coils are made from advanced alloys that, when cooled to extreme temperatures, allow electricity to flow with zero resistance, creating massive magnetic fields. To achieve superconductivity, the magnets are bathed in liquid helium, bringing their temperature down to a staggering -269 degrees Celsius. Installation is a delicate dance of power and precision, as these heavy units are bolted into the bogies with sub-millimeter accuracy by automated systems. Every fastener is tightened to an exact specification, monitored by digital sensors to ensure that nothing comes loose during the high-stress operation of the train. When energized, these magnets create a force powerful enough to lift the entire multi-ton train 10 centimeters off the ground, eliminating all wheel friction. The U-shaped guideway and the onboard magnets work in harmony, providing both the lift and the propulsion needed to reach supersonic-like speeds on land. Continuous monitoring of the cryogenic systems is vital, as maintaining that near absolute zero temperature is what keeps the L0 Series hovering in mid-air. With the magnets in place, the train is no longer a static object, but a floating marvel of physics, ready to be outfitted for its passengers. Part 5. Interior and Control. The transition from industrial powerhouse to luxury transport begins as the cabin is filled with Zen-Inspired Japanese design. Ergonomic seats are crafted from ultra-lightweight materials, designed to cradle passengers in comfort, even during the rapid acceleration phases of the journey.
Push it right up against the last one.
Got it, looks perfect.
The interior panels are made of advanced composites that offer superior sound insulation and fire resistance, ensuring a quiet and safe environment at high speeds. The pilot's cabin is a digital fortress, featuring level 4 automation systems that can navigate the entire route with minimal human intervention for maximum safety. State-of-the-art touch interfaces allow for real-time monitoring of every subsystem, from magnetic health to cabin pressure and passenger entertainment systems. The lighting system is designed to mimic the natural progression of the day, helping passengers stay refreshed during their ultra-fast cross-country transit. Every detail within the cabin is optimized for a premium experience, balancing the raw power of the technology outside with a serene atmosphere inside. Precision is even found in the smallest details, like the silent, soft-close mechanisms of the storage compartments, reflecting the high standards of Japanese quality. The windows are specifically engineered to provide panoramic views while maintaining the structural strength necessary to resist the massive air pressure changes in tunnels. Part 6. Final inspection and rollout. The journey is almost complete as the finished train car undergoes a rigorous final quality check. Before leaving the facility, every inch of the L0 Series is inspected by hand to ensure that the paint and finish are absolutely flawless. The moment of truth arrives as the hangar doors open, revealing the completed masterpiece to the world for the very first time after months of labor. Using its auxiliary wheels for low-speed movement, the train emerges from the assembly plant, ready to be transported to the Yamanashi test track. From above, the sheer scale of the train is breathtaking. A long silver needle designed to thread through the mountains of Japan at lightning speeds. Once on the dedicated track, the system begins its initialization sequence, powering up the magnets that will soon lift it into its operational state. In a silent act of defiance against gravity, the train rises, hovering effortlessly above the concrete guideway as the magnetic fields reach full power. Acceleration is smooth and relentless. Within seconds, the L0 Series is a blur of motion, leaving only a trail of displaced air in its wake. The engineering pays off as the train enters a mountain tunnel, the elongated nose successfully suppressing the sonic boom that would plague any other train. On the monitors, the numbers climb to levels never seen before in commercial rail, a testament to the success of the Japanese Maglev program. The Chuo Shinkansen project represents the next chapter of human mobility, connecting cities and people faster and more efficiently than ever before. For the future passengers, this is not just a commute. It is an experience of being at the cutting edge of human achievement and technological prowess. This success belongs to the thousands of engineers and workers who dedicated their lives to mastering the science of levitation and high-speed travel. The Maglev L0 Series, a symbol of Japanese innovation, a marvel of modern physics, and the fastest vehicle on the planet, ready for tomorrow. Every component, from the smallest bolt to the massive hull, undergoes hundreds of hours of testing before it is allowed to join the main assembly. Advanced sensors provide constant feedback to the central computer, allowing for millisecond adjustments to the magnetic field to ensure a perfectly smooth ride. Maintaining the cryogenic state of the magnets is a triumph of thermal engineering, utilizing vacuum-sealed layers to prevent even the slightest heat transfer. Even when the sun sets, the production of the L0 series continues, as highly automated systems work around the clock to meet the future's demands. Simulation and reality must perfectly align. Every data point from the test runs is fed back into the design process to constantly refine the vehicle. Optical sensors and radar work together to scan the Guideway kilometers ahead, detecting even the smallest obstacles or changes in the track's geometry. The use of advanced composites throughout the train ensures that it remains as light as possible while retaining the strength of industrial steel. Safety is paramount. Multiple redundant braking systems, including aerodynamic drag and magnetic resistance, ensure the train can stop safely from any speed. The iconic white and blue livery is more than just aesthetics. It is a specialized coating that protects the aluminum from the harsh outdoor environment. Passenger comfort is guaranteed by a sophisticated climate and pressure control system that masks the extreme external environment of high-speed travel. The infrastructure is just as impressive as the train itself, with thousands of propulsion and levitation coils precisely installed along every kilometer of track. Every safety protocol is tested and retested, from emergency exits to communication links with the central control hub
Comms
in
check
Tokyo
complete.
or
All
Osaka.
systems registering
Despite
green.
its incredible
Ready for
speed,
activation.
the Maglev is designed to be an environmentally friendly alternative to air travel, with zero direct carbon emissions. The L0 series gracefully traverses the landscape, representing a harmonious blend of high-speed technology and the natural beauty of the Japanese countryside. Aerodynamics is the silent partner of speed. The meticulously shaped nose allows the train to pierce the air with the efficiency of a jet. Calibration is a continuous process, ensuring that the magnetic lift is always perfectly balanced for a smooth, vibration-free journey for all passengers. The transition from rolling to flying is a seamless moment of engineering brilliance, as the train leaves the physical ground to glide on magnets. The stability of the Maglev is unmatched. Even at 500 kilometers per hour, the ride is so smooth that a glass of water remains still. Witness the power of the L0 series as it passes, a symbol of human ambition and the relentless pursuit of a faster, more connected world. Thank you for joining us inside the production of the world's fastest train. The future of travel is here, and it is moving faster than ever.